Hello, everyone who is watching. Thanks for checking out this Mapbox AR webinar on doing 3D visualizations in Scenekit. I'm Jim. I'm an engineer who works on all of our augmented reality tools at Mapbox. And I'll be talking a little bit today about kind of generally what's possible in AR, why you might use it, and then dig into your options for augmented reality using Mapbox and how they're useful, and then get into some very specific examples and look at some code on how to get started in Scenekit. Yeah, so let's get into it. Well, to get started, what is augmented reality? We kind of know what virtual reality is. You kind of strap on a headset. You can look around and kind of freely move through the space. Augmented reality has a lot of similarities to that, but the main difference is that the virtual content is overlaid on the real world. So in VR, you have complete control over your user's environment, and in augmented reality, you have to kind of compromise between what's surrounding your user and the virtual content you're trying to add to it. In our case, we're going to be adding a map to that environment, but a lot of the rules we're talking about and the practices we want to try to apply in order to make usable experiences apply to just about everything. All right, so we have a little bit more deep nomenclature at Mapbox on different types of augmented reality experiences. We kind of bucket them into two categories. We have tabletop AR experiences and like world scale AR experiences. And the difference between these two, I think, is obvious from this little illustration. The tabletop is really about the few meters around your user. So they can kind of engage using stuff like plane detection with surfaces nearby. They can drop objects on the world and let them interact with whatever sort of mesh or surface is detected. And they're really limited to operating kind of in that indoor environment, the sort of conference room table experience that you've seen in a lot of videos before. And then we also have the kind of world scale experience, which takes that it uses map data to take that augmented reality information and push it out into the world beyond those immediate few meters. This is cool in the context of outdoor experiences, but there are a lot of calibration and localization challenges that are definitely beyond the scope of the talk we're doing now. So I think we're going to stick to the sort of tabletop environment in Scenekit, at least for now. But there are definitely a ton of resources. If you just check out mapbox.com/AR, there's a ton of places you can get started, particularly in Unity for world scale AR. So looking more at like what the breadth of tools are that are relevant to augmented reality work, we have sort of three main contenders here. We have Unity, which is really about, it's by far the most mature tool that we can use to do augmented reality experiences. The SDK has been around for quite a while, and it supports quite a few different platforms, both tabletop and world scale. So if you're just getting into augmented reality and you want to play, Unity might be a good place to start, because you can kind of get going easy with a lot of example scenes and a lot of existing support and kind of answered questions. The other two platforms are definitely a lot newer, but they have a very specific kind of set of use cases that I think are very relevant. So in React Native, it's really about prototyping quickly in a multi-platform way in code. So where Unity has kind of a bloated installation and you can really only develop in Unity, React Native lets you develop in React and tools that you already know, if you are a React developer, and lets you kind of just get started from a known position with this 3D AR content. And then Scenekit, which is what we're talking about today, is kind of a similar role as React Native, but specifically for iOS. Scenekit is sort of the go-to 3D sort of game development environment on iOS. And I think if you are starting from a place where you work in iOS, that's the platform to use for sure. All right, so that's sort of the breadth of what you can do, but we're going to dive very specifically into Scenekit now. If you're interested more in the other platforms, yeah, you should definitely check out some documentation on those. We have a lot of videos and stuff as well. All right, so before we get started with the kind of code and the how-to part, I want to look at some of our kind of basic use cases or example cases that we've seen people playing with here. The first of which is a kind of simple demo app called HotStepper. It's a great example of world scale augmented reality that you can kind of just play with. It doesn't have like I don't know, it's just fun. It's this little guy, he walks around. He uses our navigation SDK to route from place to place on the street, and uses Unity to put this little animated character in the environment. Some of these shots are real and some of them obviously aren't, but you get the sense for kind of placing creatures in the environment and engaging with them at a bigger scale than just your desk or your chair or wherever you are. An example that goes kind of between 3D and AR, which is where we live in this demo as well, is slopes. This uses our terrain node in Scenekit to place a real route, a real ski route, and kind of lets you explore in 3D what that route looked like. And then you can also place it in augmented reality right from there. So we're going to be looking at creating an example that's kind of like this in tabletop. And the output in augmented reality will kind of look something like this, where you get a terrain node floating over your like table or surface, whatever has been detected, and then some data visualized on top of it. For the purposes of exploring the APIs from our Scenekit SDK, we're going to focus on the 3D content. There's a lot of examples out there to follow for how to get any 3D content into augmented reality, and there's some boilerplate that we're going to skip over today, especially for the purposes of demonstrating what the output of a build is. So let's get into code, and you can see what I'm talking about here. But so for every augmented reality scene, you need to generate some kind of 3D content to live in that space. And so our focus today is going to be on how to generate a terrain node, which is kind of the entry point into generating 3D content from our map data. And then how to add some points of interest on that terrain node, and then we'll kind of leave it open for you all to take from there. So here I've stubbed out like a very simple example scene. This is pretty much what you get for free when you turn on Xcode. You get a little view controller and this view did load method, which happens right at the start of your app. Over here, I've got kind of my cheat sheet for content that we're going to add, and this is my simulator where we'll see what's happening as we build. So this is the result of the code you're seeing right now. It's just like a simple black screen. Great. Let me double check actually, Avi, can you check? Yeah. All right, we're looking good. So we've got our screen. We're going to start by just maybe stubbing out exactly in comments what we're interested in doing. So I think we're going to do just maybe 3 things. We need to set up our like Scenekit view. We'll call it a scene view. We want to create a terrain node. And then we want to add points of interest. We're going to do those kind of in separate functions and then figure out where to plug them in this viewDidLoad method as we go. So the first and easiest thing to do is set up a scene view. So I'm just going to grab this content here and drop it in. Setting up a scene view is really just kind of doing the basics to get a camera and some background lighting and geometry into your scene so that you have a point of view to look at our terrain from. So we're going to define our scene view, which is essentially the camera and the rules for rendering, and then define the scene, which it's like the set of nodes, the set of geometry that we're going to render. In our case, we're just going to have a piece of terrain and some points of interest on it. So that's not enough, though. We actually have to initialize it. So I'm going to grab this setup scene view function here as well. And then we'll talk through exactly what the contents of this are and why we need it. Yeah. So here in our setup scene view method, we're going to add it to the subview, define some default camera controls. This is really just for testing. Define our camera, which is going to be offset a little bit with the Z value, and then add a light so that we can actually see what's going on. It's pretty straightforward. So now I think we'll just call that method on view did load, and we should be good to go. So now that we've got this, we should see kind of a white environment here in our simulator. Now, one important thing to note is that I have already downloaded the Mapbox Scenekit SDK from our repo. If you need more info on how to get started with that kind of installation process, we have a pretty complete README that shows you how to use different dependency managers like Carthage or CocoaPods to get the Mapbox Scenekit framework into your project. I'm kind of glazing over that piece right now. You can see I've imported the Scenekit framework, and also core location. We'll use those both in our demo, but yeah, make sure to follow those installation steps before trying to add content like this into your project. So now we've got a white scene. That means we've got lights on, camera on. That's great. But we need some kind of terrain. So I've got this general create terrain function here. I'm just going to select it and grab it, and we'll talk about what the contents of that are. So once we load, we want to define the terrain node. We haven't defined it yet, but I'm going to do it right here. Yeah, let's just do this guy. So I want to define a terrain node, and then for our purposes, I think it's easiest to define a terrain node scale up front, so that we can make adjustments once we're in the scene. Depending on where your camera is and the size of the room you're in, the terrain node might need to change size, and the geometry generated by our SDK can tend to be almost world scale depending on the zoom level you choose. So you can see we've, just for simplicity's sake, we've kind of fudged in some really small numbers here to get it down to the right size where we can think about the scale that we're using a little more easily. So now that I've defined terrain node and terrain node scale, there's one more thing I need to add, which is our actual terrain node bounds. So that is, we're just going to use the bounds of San Francisco here. I used Mapbox Studio to grab these latitude longitudes. You can kind of just use whatever method you're most comfortable with. Yeah, I happen to like the method for Mapbox Studio, but all you need is a min lat, min long, and a max lat, like a northeast and southwest corner. All right, so let's see what we have completed here and what we haven't. So we've got our terrain node initializing, and I think we'll leave all this stuff out for a second here. Actually, let's just get to it. There's one more piece that's relevant to adding this terrain node, and then we'll kind of step through what's actually happening in this code. That is what this default materials method is for here. So when we add a terrain node, the SDK generates a ton of geometry. It generates like sidewalls and a bottom, and then the kind of topology of the environment you chose. Leave that for a second here. So now that I've got my terrain node defined, I want to define the default materials that will apply to that. Now materials are kind of a Scenekit concept. They're kind of a 3D rendering concept where you define sort of the color of the geometry, And then you can give it a name optionally. We've done a few so that it's a little more readable. So here, this is a function that you'll find in all of the example scenes in our SDK as well. It's pretty straightforward to add to your scene, but the idea is to define a bunch of materials that will apply to the different faces of the final terrain node. And here we can do things like change the color or make even more detailed edits based on what's possible with this actual scene material. I'll let you explore the docs on scene material to get more info on exactly what you can do. But this is kind of the bare minimum to get going. So once we've defined the material, we just simply add the terrain node to our kind of scenes root node. And this is where the real magic happens. So without that, I'll just comment it out. The last thing we need to do is create terrain. Nice. All right. So now we've got our terrain node being defined. We have defined our latitude and longitude, and then we set up the scale on the materials and add it to the scene. That's not quite enough to get going. I'll show you what happens. So the reason this isn't going to work is because there are kind of two layers of data that we use to populate the content of our, oh yeah, there we go, terrain node. But there are two layers of data that we use to actually populate the materials and the geometry in this node. The geometry is generated by a method called fetch terrain heights, and that uses the Mapbox API to request our terrain RGB data, to request the heights and elevations for the region that you're interested in, and then generate complex geometry and normals and all of the stuff you need to do lighting right in this method. So I'll just uncomment that, and we can have a look at what's actually happening. The reason these are separate methods and don't happen right when you instantiate terrain node is because we want to be able to pass in our own callbacks for progress and completion, and then do something else maybe when the terrain node is loaded, or when the heights are loaded, or when the texture is loaded. And since we broke those out into separate methods, we can handle those callbacks as they come, I think a little more intuitively than passing a ton in on the instantiation. So now that we've broken out, or we've uncommented this fetch terrain heights, we've just defined the wall height, which is how tall the kind of side walls, the border walls are going to be. Dynamic shadows is, it creates the normals. If you know what normals are, they're sort of how shadows are cast and handled. It's important to keep that enabled if you're going to do anything with realistic lighting or physically based lighting in your scene. And then here we just have an empty progress method. This is where you would kind of update a progress bar if something is loading. And then on complete, we're just going to call this, or we're just going to log this line of text here. So once this builds, you'll see exactly kind of what happens on the terrain node. So now we've generated the geometry, and you can see the heights, but you don't really see much in terms of visual interest because we haven't actually generated any text or any texture yet. So we're going to use the second kind of base method on terrain node, which is the fetch terrain texture, to get the satellite texture here. This is just the default Mapbox satellite RGB, and define a zoom level. Higher zoom levels are going to be more crisp, but they'll take a lot longer to load. And then once that's complete, we get an image, and we want to apply that image to our diffuse contents. The diffuse contents of a material are sort of the basic color of the surface. So it's if the diffuse contents are gray, then the whole surface will appear gray. If the diffuse contents are an image, for example, then the surface will appear with that image. And we're using the fourth component in this array because that's the top of the cube we generate. This is obviously not the most intuitive, but once you get a sense for how the geometry is generated, it's easy to see why number 4 is at the top. But it's really just good to know. This also is in all of our examples too, so it's not something you have to really memorize. But once we've got that image done, or the fetch terrain texture done, you can see this is sort of like the basic visual that's output from our terrain. So it generates the texture almost always faster. So if you want a 2D map that pops into 3D, you can do that. And then the terrain loads after. And now we have our kind of map of San Francisco. Nice. Now, if you want to accentuate the height or the shape, you can do that just by changing the scale of the node. I'm going to leave it. I'm going to leave it as it is, though. All right, great. So we've got our terrain node. We've got everything kind of set up now. I think our next step is to add points of interest to the map. So I'm going to do that with this add POI markers function here. We'll add it and then step through what it does. Yeah. So for the purposes of this example, I'm just going to include some kind of hard-coded locations that I've already planned. You can use the iOS SDK if you're a little more experienced. You can use the iOS SDK to query features on a custom map style and add those as coordinates. But that's a little bit of a lengthy process. Obviously, the Scenekit SDK is in early beta, so some of these features are going to be they're going to be coming. We'll be making this process easier and easier, but it's definitely achievable right now. But for the purposes of brevity, I think we're just going to go with a hard-coded set of coordinates. And then once those coordinates are defined, we're going to iterate through them and add just a simple sphere marker based on some height that I defined. Now, the real magic happens here in this position for location method. This is really the last big tool that you need to know if you're going to use the Scenekit SDK. Position for location takes a core location and turns it into a position, a SCN vector3 in scene space. That lets you work in the same coordinate space for all of your kind of game objects or visualization objects without having to worry about like the lat long conversion or anything like that. So once we do this conversion, we just add the sphere marker directly as a child to the terrain node. And that lets us do things like move the terrain node and have all of our markers kind of follow along. So now that I've defined that points of interest or add POIs function, we want to call it. But we can't call it from where we created the terrain node because we want to make sure the geometry is loaded so that position for location gives us the right value. Because without it, it's just going to kind of drop on a flat plane. And then once the geometry loads, it'll pop in. And we don't want that. So once the terrain heights method is complete, that's what gives us our geometry. We're going to do add POI markers right there. This way we know we'll have the terrain heights loaded and the POI markers will spawn right where they need to. The closure, I have to do this guy. All right, so now we've added POI markers to our scene. Let's see how it looks. All right, great. So now we can see the terrain is loaded. Then then it iterates through all those points of interest and adds those blue spheres at each location. So once I zoom in, if I can zoom in, sure. Not on the simulator. But you can see in that add POI markers section, I did stuff like define the color using that same diffuse contents method that we talked about using for the terrain node itself, or this same parameter here. And then I've actually cheated and added an extension to define the Mapbox color so that I don't have to do RGB numbers. Then I define the position using position for location. That's great. And I just do a simple offset before adding it as a child. That's why it's kind of floating above. Now, you can kind of extend this method to add kind of text or banners or custom models, whatever is of interest to you, or whatever kind of communicates the story that's relevant to your experience. But this is really the basics of getting these components all into a single scene using the APIs available in the Scenekit SDK. If you've got any questions on this, you can follow up, and you can follow up by actually, I can answer them right in the chat if you have any questions and are interested in getting answers right now. If you have questions as you work, definitely add tickets or issues to the Scenekit SDK repo. Oh, we'll give it a second in case any more questions come in, but we'll start looking here. But you can definitely also, if you're having problems or confusion as you are building these experiences out, you can drop a ticket right on the Scenekit repo, and we'll see if we can help you there too. Yes. So the question is, for handling long distances between POI markers, is it best to decrease the zoom levels on the terrain node? Yeah, that's exactly right. This is something that our other SDKs handle automatically for you. But as you increase the space between these lat longs, you also are going to need to kind of feel out what the right zoom level is. The bigger the space, the smaller the zoom level needs to be. I found generally, if you're going below 8, then you're probably looking at like the continental US. But that's kind of the idea. You can also, if you look in Mapbox Studio, this might be a good way to anchor what you're thinking. I do this actually all the time. If you look in Mapbox Studio, any style, you can see the zoom level that you're at right on the side here. So if you get a sense for like, I'm looking at this much terrain on my terrain node, you might want to use this zoom level to get that terrain. That's probably a good answer to that input. And where you define the zoom level is actually right here on the fetch terrain texture. So you can see I'm using zoom 14, but yeah, you can use whatever. Now, as you zoom out, you might want to zoom. You might want to update the terrain zoom level as well, but that's a little bit hidden. Yeah, I would check. I think we still need to expose the terrain zoom level in our APIs, but that's an easy to do. You should get away with using the default anyway. So I'll answer a couple questions here that I'm getting. Let's see. So the first one I'm seeing is React Native examples. Sadly, I am not an expert at React Native. I don't think we have any examples to share now. We can definitely. I would check out the repo. If there aren't any examples there, there will be soon. But we're working on fleshing out kind of these starting points as we go. If you have any interest in React Native or any specific functionality you need, you can drop a ticket there too. Let's see. So yeah, the Mapbox SDK doesn't have any dependencies on ARKit. Or I guess the Scenekit SDK doesn't have any direct dependencies on ARKit to work. It's just a pure Scenekit thing. ARKit kind of works on top of that. if you're looking at stuff like Unity, we include a lot of examples that depend on ARKit and ARCore. But those definitely aren't mandatory for your scene. All of the mesh generation and tile fetching and all that stuff is pretty agnostic. And then I think the last one I see is so the Scenekit SDK doesn't support any caching right now. I see a question about retrieving data about terrain heights offline. This is something we definitely are tracking, but there's not even ambient caching right now in the Scenekit SDK. Yeah, so I can, for the AR piece, I can show you a little bit of content from our examples. Sadly, I can't screen share it because you can't really do much in the simulator in AR, but I can definitely point to a few of the methods that are relevant in our SDK. So what I'm going to do now is navigate away from this example scene just to the SDK itself. In order to look at these examples, you actually have to clone the SDK repo rather than doing like a Carthage update or a dependency update. But once you've done that, let's see if I have it. So in our Scenekit SDK here, we've got a AR view controller. And the reason I excluded it is because, or at least in the basics, is because it doesn't, all of the complexity of adding stuff to AR doesn't really touch any of our like core SDK APIs. It's really about adding kind of additional boilerplate to get the Scenekit or the ARKit scene up and running, and then creating some methods using the ARKit delegates to respond to events. So a simple example of what I'm talking about here in the ARKit example, which is very long, is on viewDid load. Here there's a bunch of AR configuration options. These aren't really relevant to our SDK, and there's a ton of documentation on Apple's documentation site for ARKit that lets you kind of dig into exactly what you need to get a scene started here. So that's where I would point you if you want to go farther into the augmented reality side. I think I covered the caching stuff offline. Oh, okay. So I see one about adding a style in Mapbox Studio. Yeah, that's actually very easy. So if I go back to this sample here, this fetch terrain texture, this is actually a style ID. So the Mapbox Satellite V9 is the style ID I chose to get this satellite view, but actually I can just do it here since I'm in Studio already. I can grab like this basic template style, copy the style URL, and drop it right into, yeah, right here. And that should give me the style that I chose. Uh-oh. Right now. No, we have to edit it. So we'll start with this one. I think I might be making some mistake here. This is the idea. These textures should work. So there we've got an outdoor style. I think what I'm seeing right now is that we're kind of limited to our outdoors, kind of our default styles. But I'm certain there's a way.
Yeah, I think it's all just in how you wrote.
this thing. I was kind of messing with it, but it might be wrong. But I think it's just in how that's compared right now. So I do know that our, let's see. I'm sorry, I don't have quite the right answer to that, but I am certain that you can define your own styles. It's just a matter of formatting the API or the URL correctly. I think I might have to get back to you on that. Avi, if you can respond in the. Sure. I'm sitting with a colleague Avi here who is going to respond with some more detailed classes to investigate for that, specifically for the custom styles. In the comments, we should be able to. Doesn't want to let me. All right, you know what? Let's get into some more questions here. Yeah, that's Stephen. I'm pretty sure you're correct. I haven't actually done the custom styles yet, but there's the Mapbox HTTP API class that I think is relevant to that exact custom styles question. If you want to add that question to the SDK or to the SDK repo as an issue, we can follow up there with a lot more detail too. Are there any other questions that are? All right, so there's one last question about cross-platform functionality. There are parallels across every platform, but sadly, because of the nature of the teams that work on them, the nomenclature might be a little different. So for example, in Unity, this position for location method is actually called geo2world position. That's just one example of kind of the same functionality existing with slightly different, I guess I could say like slightly different nomenclature or slightly different APIs. It's not the easiest to get a hang of, that's for sure. But yeah, I would check out, if you're specifically looking for Unity, we have pretty extensive documentation on the APIs. But yeah, you can get it all done on every platform. Yeah. Is it possible to switch table AR experience on this kind of height map to world scale AR? So I would say in world scale AR, if that's your goal, I would jump on Unity as quickly as possible. We are working on getting a world scale example built out in Scenekit, but it's a little more involved because the specific use cases are not as clear to us in terms of integrating a current map into an iOS app. If you're interested in world scale stuff, you shouldn't let that deter you. Unity has a lot of great examples on how to build that stuff out. But right now we're still experimenting. You can do something simple like add a giant terrain node and put the camera on the surface. But obviously it's a little more complicated than that. All right, well, if you have any other questions, I'll stick around for a couple more minutes, but yeah, I hope this was helpful. Let me know if, or I guess let us know on the Mapbox Scenekit SDK if there are any other questions you have or issues you run into. We'll try to track that as close as possible, especially in the next few days while you guys build out these Explore Outdoors challenges. All right, thanks for watching, y'all.